Okay, I'm going to play around with this. I've done it before, but never recorded anything of it. It's, pardon me. It's an example of a sort of magnetic levitation. Let's see. What you're looking at is sort of a close-up. There's a lab stand here. Here and here are clamps. They're made of plastic, non-magnetic materials. The screws for them that operate the clamps are non-magnetic stainless. It's important. The top clamp holds a bismuth slug, as does the bottom one. And positioned above all this is a stack of magnets. I'll pan it back later and show what this thing looks like. It's not very complicated at all. What's shown here is a neodymium magnet. It is suspended in there. It is levitated. By virtue of gravity pulling it down, by virtue of these magnets up top pulling it upward, and by virtue of these bismuth slugs, which are diamagnetic, which basically means, unlike paramagnetic materials, iron and so forth, magnets are attracted to those. This material is diamagnetic. It repels magnets. Good Lord knows I don't want to get into a discussion of how that should be, but think of it as a mirror. This material presents a sort of a mirror image to the magnet, just a little bit. And because of that, you can get a balance going. As I've said, I've got magnets from above pulling this up. I've got gravity working, pulling this down. And between the two of those, you can get a fine balance where it can actually levitate if you've got it surrounded by a diamagnetic material. Bismuth in this case. Graphite is another material that has that property. And I've seen it done with graphite. Now, this truly is floating here, and it is very touchy. I'm just pulling up very slightly on the top of this lab stand, and I've got the top magnet on a thread, so I can really precisely tune this to where it's not touching the top nor the bottom of bismuth. The gap between the two diamagnetics is critical. It's too big, it'll drift up or down. Too small, one side or the other will touch, but you can get it to where that magnet in between there is not touching anything. You can see it's just kind of rocking back and forth like a pendulum, and that's because it's not, the magnet itself is not perfectly balanced, and I don't think its field is perfectly distributed. Its magnetic field is perfectly distributed. For whatever reason, it's leaning a little bit to one side, and it's trying to find, gravity it's trying to find that point where the pendulum stops, and it'll rock like that for a long time. Post-it piece of paper here, post-it note. You can just slide this underneath. Slide it up above. And there's nothing at all attached to this magnet. And the only thing holding it there is gravity and magnets. So you're going to give this a spin like that. Oh, come on. Gotta get good aim. You can do better than this. That'll work. Yeah, you can see spinning. It'll go like that for something like 10 minutes or so. To do this and make it bottom out, it'll stop it. But this is suspended here. It's not in contact. It's not in physical contact with anything here. And I just put it in a lab stand to demo it for my friends. I've seen guys that have made some pretty cool permanent sort of artwork pieces that do this. I'm not going to go to that trouble. This is just a lab stand, and well, let's see. Maybe go ahead and yeah. Let me stop this. I'll patch on another vid that shows, or maybe a still that shows the setup here. See. Okay. This shows the basic setup. Is not very complicated. Bismuth slug here. These, by the way, I cast them. The stuff, very low melting point. You can do it on the stove. It's not particularly toxic. Don't worry about that. Don't use the wife's stainless measuring cups for this. But anyway, these are about 1 inch in diameter, about a ½ an inch thick. It's not critical. I ground a crown on one side of each of these. I ground the crown on one side, slight convex to it, and on the other side of each, I ground it flat. Thinking that the convex would keep it. It would keep the magnet, tend to keep it centered. It seems to work better with the flats. And what really controls the position of the magnet in between these two is the position of the magnets up here. And the slightest touch. I mean, oops, daggone it. Give me my light back. The slightest touch, you can see that I'm moving this thousandths of an inch, and it's having an impact on where that floating magnet tends to want to sit. And same thing with lateral, and every dimension. It's very touchy, and it won't sit like that forever. There are other things that affect the temperature. Lord, maybe even humidity does. Time of day, where the sun is, the tides, may have some impact on anything that would affect gravity or magnetic field. It's going to impact this. Leave it up to you to guess what those things would be. So, yeah, it's not going to be a permanent installation or project by any means. Just want to demo something. I had this crap laying around, so why not? Right? It's fun. See.